talked about simplifying sets, how to simplify sets. When a number is under a square root, it doesn't necessarily mean it's a set. Sometimes simplifying it clarifies whether it is a set or it isn't. And so in this lesson, we are going to deal with that. We are going to start with an example as it clarifies things a lot. Square root of 75. Square root of 75 can be expressed as square root of 3 times 25. The 75 has been reduced or simply rewritten as 3 times 25, which still gives 75, right? It still gives 3 times 25 still gives 75. Then, like we've already seen, 25 can be expressed as 5 to the power 2 or 5 squared, while still maintaining our square roots, right? Now 5 squared will be 5 because, like we learned in the previous lesson, the square root is a number to the power half. So 2 times half gives us 1. So we get just 5 times the square root of 3. 3 can't be reduced in any other form, and so we keep it, and thus we get from here this becomes 5, and then this is not changed because it can't be reduced any further. Thus we get 5 times square root of 3, or 5 root 3 for short. This is all about simplifying sets, just reducing it to the simplest form possible. Okay, so we can take 20 for instance as well. 20 can be expressed as 4 times 5. 4 5 is 20, all under a square root. Now we can separate the square root of 4 and the square root of 5 as this. We recall we can rewrite 4 as 2 to the power 2. Right, we can rewrite 4 as 2 to the power 2, and then we keep the square root of 5. This time around the 5 is not to the power 2, so we just keep it because we can't rewrite it any other form. Now 2 to the power 2 under the square root becomes just 2 because the square cancels the square root, and so this is what we get: 2 times square root of 5, and then finally 2 root 5. This is how we simplify sets. At times you may encounter huge numbers under a square root. This we moving forward ahead of time, but take square root of 270 and then square root of 120 for instance. How would you be able to know which numbers to multiply what so that we get numbers that cancel out? So an easy way is to write the prime factors of the numbers, and how to write the prime factors of a number has already been taught in one of the videos. You can check it out. It will be linked to the description so that you can easily find it out if you don't know, but if you know, then kudos to you. So if we are to find how to get the number that will multiply to get 120 or 270, we can use the prime factorization of it. So prime factorization of 120, here 5 times 24. And again, if you want to know whether 5 can cancel 120, check the videos on divisibility rules, which is also which will also be linked in the description. Alright, now eventually this is what you are going to get for the prime factors of 120. This is what you are going to get. Great. If you don't understand how, please check the video on it. You realize that you have 2 appearing 3 times. Now it means we can have at least 2 to the power 2 or 2 squared, right? Because 2 appears more than 1. So we can take these 2 numbers and then the other 3 numbers. So we isolate the number that we can rewrite as squared, and then the others. Great. So 2 times 2 is 4. So we can keep that one and then multiply the other numbers. 5 times 2 is 10. 10 times 3 is 30. It means that 120 is 4 times 30. We can keep that, and then we come to 270 as well. When we write it in its prime factors, this is what you are going to get. Now you can see that this time around it is 3 that appears more than 1, and then it means that we can at least express 3 to the power 2. That is 3 times 3. So we isolate that. If it is more than 3, then we can actually do 3 squared times 3 squared. But this time around it is just appearing 3 times, so we take 2 so that we can express it as a squared. Then we take the remaining numbers. So this time around we isolate 2 of the squares and then multiply the other numbers together. So 3 times 3 will be 9. Then 5 to 10. 10 times 3 will be 30. It means that 270 can be expressed as 9 times 30. So that's how you know how to write complex numbers in a set form. You just take the numbers that appear or can be expressed as a squared and then multiply the rest to get the values you need. So 270 can now be 3 squared, which is 9, times the other numbers left, that is 5, 2, and then 3, which is 30. Great. The same thing happens to 120. So we have 2 times 30. Now you can see that 30 cannot be reduced any further, but 9 can be rewritten as 3 squared, which is what we got here, 3 squared. And then 4 can also be expressed as 2 to the power 2. Great. Now we have something in common. Root 30 is here and then root 30 is here as well. But we know this to the power 2 cancels out. This to the power 2 cancels out. So we get 3 root 30 minus 2 root 30. This is how we simplify complex sets. Now we would move on to addition of sets next because you've introduced this. However, this is how you reduce complex sets. Great, this gives root 30, but then we'll explain this further in the next topic. Alright,